In section 4, we're going to talk more about parallel lines and proportional parts, specifically in triangles. So to start off, we're going to talk about a theorem called the triangle proportionality theorem. And it states that if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it separates these sides into segments of proportional lengths. So if we take a look at what that means, we have our triangle ABC. We are going to draw a parallel line DE in that triangle. So we know that DE is parallel to AC. So if DE is parallel to AC, then we have that AD BD over DA is going to be equal to BE over EC. So that parallel line breaks the segments into proportional lengths. So it's not just that the whole thing will be proportional, because this does create two similar triangles. It also means that it breaks the lengths into proportional segments as well. So let's take a look at this in an example. So in our triangle RST, we have that RT is parallel to VU. We know SV is 3. We know VR is 8. We know UT is 12. We want to find SU. So I'm going to label it that next. So because RT and VU are parallel, by the triangle proportionality theorem, we know that SV over VR has to equal SU over UT. We're going to use this to help us solve for x. So that leads us to plugging in what we know, that 3 over 8 is going to equal x over 12. Then we use cross products to solve. So we get 3 times 12 equals 8 times x. 3 times 12 is 36, so we get 36 equals 8x. Divide both sides by 8, and we get that x equals 4.5. So we know that SU equals 4.5. There's also something called the converse of the triangle proportionality theorem. It states that if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional length, then the line is parallel to the third side. So converse just means opposite. We have seen this wording before in Module 3. So converse just does the opposite. It starts with the end and wants to prove the beginning. So in our triangle proportionality theorem, we knew the line was parallel and we used that to get proportional lengths. But now we're starting with the opposite of that, the reverse. We're starting with the proportional lengths and using that to say that the line is parallel. So if we use the same triangle as before, triangle ABC, and we have our segment DE. This time we're starting off with the fact that our segments are proportional. So if BD over DA equals BE over EC, then we can state that DE is parallel to AC. So knowing proportional lengths tells us that that line has to be parallel. So we're going to go ahead and do an example. So in our triangle DEF, we know that DH is 18. We know HE is 36, and DG is 1/2 of GF. We're going to use this to determine whether GH is parallel to FE. So if it is, then we have that DH over HE should equal DG over GF. As long as this is true, then that line is parallel. So we know DH is 18. We know HE is 36. And while we don't have a length for DG, we know it is 1/2 of GF. So we can replace it with 1/2 GF over GF. So using our cross products, we get 18 times GF equals 36 times 1/2 of GF. So my left side's going to become 18 GF, and then my right side, 36 times 1/2 is 18, so we get 18 GF. So we get 18 GF on both sides, which means our sides are proportional, which means that GH is parallel to FE. It is parallel. If we hadn't gotten the same thing, then the length would not have been, the side would not have been parallel. We also have something called the triangle midsegment theorem. So it states that a midsegment of a triangle is parallel to one side of the triangle, and its length is half the length of that side. So in our triangle ACE here, we are going to construct the midpoints of each side, label those B and D, and then connect those midpoints with a segment. So we know B and D are midpoints. They split their segments in half. So based on this information, we know that BD is going to be parallel to AE. And we also know that BD equals 1/2 of AE. And this is only because B and D are midpoints of AC and CE. If they were not midpoints, we could not make the statements that we did. So we'll go ahead and use this in example. So in our figure, OA is a midsegment of our triangle MTH. We want to find X and Y. So because it is a midsegment, we know that MO and OH are congruent. We also know that MA and AT are congruent. We're going to use that fact to solve for X and Y. So we know that MO and OH have to be equal. So we know 1/3 X plus 2 equals 2/3 X minus 4. So we're going to use this to solve for X. So I'm going to subtract 1/3 from both sides. So we get 2 equals, well, 2/3 minus 1/3 is like fractions. So we end up with 1/3 X. And we add 4 to both sides. We get 6 equals 1/3 X. Finish solving for X, we multiply both sides by 3, and we get that X equals 18. Now we're going to use the fact that MA and AT are equal and say that 5y equals 7/3 y plus 8. So we're going to subtract the 7/3 y. But 5 and 7/3 are not like fractions, but we can rewrite 5. 5 over 1 is the same thing as 15 over 3. We multiply the top and the bottom by 3. So we're really doing 15/3 minus 7/3. And when we do that, we get 8/3. So we're going to have 8/3 y equals 8. My first step is going to be to multiply both sides by 3. So we get 8y equals 24. Then we're going to divide both sides by 8, so we end up with y equals 3. And if we were to plug x and y into those lengths, we would end up with two segments that are congruent on each side. In our last examples, we are going to find missing side lengths using the fact that we have parallel sides. So we're going to be using that triangle proportionality theorem. So we know that these two sides are parallel. So using that fact, we know that 15 over the question mark, which I'm going to label as x, has to equal this first segment over 2. Now we don't have the length of this segment, but we know the length of the whole thing is 12. We know the length of the smaller portion is 2, which means that first portion has to have a length of 10. So we're going to use that to solve for, we're going to cross multiply, so we get 15 times 2 equals 10 times x. So we get 30 equals 10x. We're going to divide both sides by 10, and we get that x equals 3. So that question mark side length has a length of 3. In our second example, we want to find the length of the entire side here. But we're going to use our theorem to find the shorter sides so that we can find that length. So we know the entire length is 24, which means this portion at the top is going to have a length of 9. So we know 9 over 15 has to equal, now we don't have enough information to find that small portion, so I'm going to call it y over 25. Using our cross products, we get 9 times 25 equals 15 times y. 9 times 25 is 225. Then we get 15y. Divides both sides by 15, and we get that y also equals 15. So x is our whole segment. It's going to be equal to the 15 plus 25. So we get that it equals 40. In our last example here, we have 3 different sets of parallel lines. So using our theorem, we know that 7 plus 14x over 22 has to equal 25 over, and then because we know whole length is 35 and this part is 25, we know that it's going to be over 10. So cross products gives us 10 times 7 plus 14x equals 22 times 25. Distributing into our parentheses, we get 70 plus 140x equals 550. We're going to subtract 70 from both sides, so we get 140x equals 480. Then we're going to divide both sides by 140. And we divide both sides by 140, we are going to get a decimal, and it's not a very nice decimal, so we are going to leave our final answer as a fraction, and we're going to simplify it. So when we simplify 480 over 140, we end up with the fraction 24 over 7. So that is the length of x, but we want to find, we can then plug that in if we want to find the length of the side. So we get 7 plus 14 times x, which is 24 over 7. So we end up with 7 plus, and then I'm going to go ahead and do the division first. So we're going to do 14 divided by 7, which is 2. And then we're going to multiply that by our numerator of 24, and we're going to get 48. So we get 7 plus 48. And 7 plus 48 is 55, which means that whole side has a length of 55. So let me know if you have any questions on the notes or on the assignment.